So we'll be starting with trigonometry. There are a few questions as you see. Now let's go in order. If it gets to a similar question, we can skip that since we will have done previously. But in such questions, what do we do without use of calculator? That means most probably we will draw a diagram. Okay, draw a sketch, draw a diagram maybe. So that's what we can say. Now, but before doing so, let's just simplify because sometimes we may not need, like as in the first step, you will see it's in the third quadrant and it can be just written as 180 plus 58. So third quadrant, it's just negative. So 1 mark is for writing negative sine 58. And because sine 58 is k, so the answer is negative k. As you see that first 2 marks, first question, we don't need the diagram anyway at all. But the second one, yes, because there is cosine and sine given. Sine is given and cosine is asked. So we can here draw a diagram, kind of a right angle triangle. Actually, we can even solve without drawing, but let's go with the general way. So what do we do then? In that case, we write then angle is 58. Okay, usually that one. Now it is k, so opposite is k, hypotenuse is 1. And then the missing side will be, remember, 1 minus inside root, 1 minus k square. Because now here diagram is 1 mark, and after you have the diagram, writing answer will be 1 mark, 1 minus k square. Okay, so what could be the other way? The other way we can always go for, like what? I can say, or use the idea of sine square plus cosine square is 1. We can always use that idea. So how does it work? You can say cosine square is 1 minus sine square. And so cosine is basically root 1 minus sine square alpha. So if the angle is 58 degrees, so we know what is the sine 58, it is k. So that's why it is root 1 minus k square. So you can get it from there as well. That's another relation. Okay. Now 5.2, it says again, no calculator. So in that case, when there is no calculator, either the angles will be special angles or some of those can cancel. Like 10 degrees is not special angle, but 80 as well, you know. They may be combined or canceling each other, whatever, we'll make a plan. Now, but for all the others, you'll just try your best in writing all angles before using calculator with the non-decimal values. We must do what? We must first write them in acute angles. So convert them, convert the angles to what? Special angles, 30 degrees or 45 degrees or 60 degrees. Okay. So, and for the others, we will be thinking identities or canceling each other or whatever. Okay, that's after that step. Okay, calculator can be used. You know that, like sine 30 is 1/2. If you don't know it, you can use it when you have 30, 45, 60. Then fine. Then you can smile. Nothing is wrong. Okay, let's do that on that side. Let me just write 10, 30 is 180 minus. It's in the second quadrant. Negative tangent 30, 180 minus 30 is 150. So it's 360 minus 60, it's negative sine 60. Sine 10, we cannot do nothing, leave it like that. And then when you divide, the other one is 225. 180 plus 225, cosine is negative. So cosine 45, 180 plus 45 is 225. And finally, 180 minus 45, but sine is positive in the second quadrant. And then cosine 80. Okay, when you come this step, you should be expected to realize 10 and 80 add up to 90. So I can actually convert 80 because they add up to 90. Instead of cos 80, I can write sine 10. And yeah, as we were expecting, they cancel. So they will cancel. And all the others, just substitute the special angle values, but write in decimals. Okay, sorry, write in fractions. So minus tangent 30 is minus root 3 over 3. And then let me write in another color. And then sine 30 is what? So that's minus root 3 over 3. That is root 3 over 2, or negative. And then divided by, that is root 2 over 2. The calculator will give you, and that is root 2 over 2. So all these things, when you type in, you can type numerator and denominator separate. That's not a problem. So that will give me negative 3. The numerator will give me 1 over 2. Divided by denominator will give me negative 1 over 2. So the answer is negative 1. Okay. So the final answer will be negative 1. It's good for 7 months. And then the questions like deriving a formula of sine or cosine from the other, it is a possible question. Yeah, they can ask time to time. You see, we will use cosine to prove the identity for sine. Now, how does that really work? Let's just take it on a separate page, so it could give us a better idea. A new page, yeah. So I just show you here quick, because we will use that cosine rule, but what we know is sine. So first step is this. Instead of, so this is my left hand side, remember? So but how can I convert this into cosine? So it is just like type 2 in general equations. Instead of cosine sine anything, I can write cosine alpha minus that. So then what does this give me when I open the bracket? When I open the bracket, I end up 90 minus alpha and minus beta. So this is not wrong, and all is fine. So now, how can I use that plus formula? You see cosine plus formula, because that's for cosine now. But what I ended up as minuses here. So then maybe I can just do one more small thing. What is that? I can say cosine minus alpha, 90 minus alpha plus minus beta. You see now, that is what I actually and exactly wanted. So it gets into that form. Which form? Look at here. It is cosine alpha plus. That's plus in between. Now I have plus in between. Okay, so imagine this is like my A, and it's like my B. So cosine A plus B. So like this angle is my A. Let me write in that way. So maybe you can see better. That angle is my A, and the second one is B. So you already know the rule for cosine A and B, like if A plus B. Okay, that's given on the top. Cosine is selfish, so cos A, cos B. So you punish him minus. Oh, by the way, that formula is given wrong, huh? So let's say minus. So you can check the memorandum how it's solved, because it could be maybe minus given. See, because the identity given is wrong, we weren't sure whether the first one is minus or the second one is minus, because one of them should be minus if you are adding them. So because I take the positive sign, I just change this to negative. Okay. So, but in the memorandum, when you see, you could find out it's other way around. Okay, what I mean other way around is in the identity it is minus, and when you express it, it's plus. Remember, it changed the signs. But anyway, let's solve the way that we had. It's minus sine A and sine B. So I know those are A's and B's, so it's just time to substitute there. So it is cosine, what is A? 90 minus alpha. And then cosine beta is negative beta. So we punish minus sine 90 minus alpha and sine negative beta. So the last step is just their simplification. You don't have any problem. You shouldn't have any problem in writing this straight from now. So sine cosine 90 minus is sine. So all these are, as you see, identities, like reduction formula. So how does it work? That is sine alpha. Cosine is positive, so that's cosine beta. So that minus, that's cosine beta alpha, sorry. And it's in the third quadrant, so that's minus sine beta. So then we can see that minus and minus. So we can write the final answer. Yes?
So why did you write cosine negative beta as cosine positive?
Because the given identity was positive. That's what I wanted to use. Okay, so cos alpha and sine beta. So that will be the answer. Now, why I do that? Because look at the given identity on the top, that's plus. So I want to write in the plus form. See, that one must be cosine something plus something, so that I can apply that rule given. Okay, but the question has a small problem because they can't be both positive. You know, the identity is either that must be negative, then I could use the just taking bracket. Now that could be easier for me, but actually we have done a little bit more difficult option. If we are going to use cosine alpha plus beta, and that is a bit more difficult. You see, that's like the memorandum could be the easier way, not the easier way, because when you choose negative, it becomes an easier question. Okay, so we have to use what they gave us. That's why I'm turning the condition into what they gave me. So I use that identity. So how did I write that thing? Using this identity, I wrote the green line. And then I just substitute the A and B values there, one by one. Okay. All right. So no, that's fine. Where are we now? So then that is fine. 5.4 is a proving question, prove identity, left side, right side. So in prove identity questions, there is a double angle rules, yes. There is tangent, sine over cosine. So we will try to look all these. So what can be done over there for this double angle questions? Now the problem is little bit with the cosine, because we have to decide which one to choose. You know that. So which identity of cosine double angle must be taken so that it will work easier. Now you see we had three options: cosine square minus sine square. You can check the formula: 1 minus 2 sine square 2 cos square minus 1. So for sine, there is nothing much worry about. It's just sine 2 sine cosine. So let's start the one with the right side. Sorry, left side. So I'll say left-hand side, and I'll write the identities. So you remember which one we choose? The one with cancels 1. Okay, that's my point. So that's why which cancels 1 is 2 cosine square x minus 1. So in the expression, we still have plus 1. So that cancels. Okay, so let me erase that so that it won't confuse. So there is sine double angle. We only have one thing anyway. So that's my cosine double angle. And in denominator, what am I going to write? 2 times sine times cosine times what? Sine over cosine. Tangent is sine over cosine. Let's do that. Let's use that identity as well. Tangent is sine over cosine. So I use those identities. I substitute the sine double angle. I substitute tangent is sine over cosine. And I don't choose cos square minus sine square. I don't choose 1 minus 2 sine square. I chose the one 2 cos square minus 1, because to cancel 1. Okay. So must be cancelled. That's the aim. Must be cancelled. If possible, you know, if it is not possible, then there's always options to think about other ways anyway, but we are just trying to solve as quick as possible. That's the point. So when you do that, what do we end up is the ones cancel. You get 2 cos square x, and then denominator. So in denominator, that cosine and one of the other cosines cancel. So you end up 2 sine square, because 2 sine and sine. So you end up 2 sine square. So actually, and the ones cancel. That's fine. And we can actually stop here. And we can just write the other one. So we end up cos square over sine square. And so it's almost done. We can work the right side separate, because what is right hand side then? If you write 1 over 10 square, and what is 10 square? You can write that in brackets, sine over cos square. So sine square over cos square. So then what will happen is, so 1 over sine square over cos square becomes cos square over sine square. So left hand side and right hand side become equal in that case. So it becomes cos square over sine square. So as a final thing, you can just write the conclusion as left and right sides end up equal. Okay, you can just say left hand side is equal to right hand side. Okay, so this was the question with the proving identity. Now there is this next question. If you look, tangent x is 2 sine x. And they want us to get the answers. So actually that equation solved into, see, that's 3 marks and 4 marks, together 7 marks. It is actually solving equation, trigonometric equation. So they just make it possible with the steps. So, but how can we even approach tangent x is 2 sine x, that type of a question? So we can basically use the identity tangent is sine over cosine. So that's actually for the first one. So you can say sine x over cosine x is equal to 2 cosine x, 2 sine x. So this is given. So from then what can be done? You can times everything by cosine x. So that gives an idea. So what does it give me if you times everything by cosine x? It gives me sine x and then is equal to 2 sine x cosine x. By the way, cosine cannot be 0 because of it's in denominator. Then such equations don't just cancel things. Okay, you have to write an equation. You have to factorize it. So that is why we take the right side to the left or other way around. So I want to take a common factor. So then sine is a common factor. Yes, sine is a common factor. That's good. And what is left when you take sine out? 1 minus 2 cosine. Okay. So from here, it is kind of easier now. I can actually, okay, I can just say it is actually done because you can just write what they want. That's it. You can say either sine x is 0 or cosine x is half. Okay, so that wouldn't be a problem. So it's basically just 3 marks for that. Tangent is sine over cosine, times everything by cosine, put everything on one side, factorize, and then. So when they ask general solution, now it is for the general solution. Now I will carry on from there. You see, I don't need to do all these things again. Or if you couldn't solve 551, you can just solve 552 using the answers before. You see, I already have the answers there. And the good thing is it's 4 marks. I don't know, like you can actually say, look at here, 4 marks. We are just going to write the answers for those things already given. Okay, so just use them. It doesn't matter you couldn't solve 551, but you can use them. Use them and get your 4 marks. It's good. So how can we use them? Just write like when sine is 0, the calculator gives you what? 0. So 180 minus 0 is 180. So x is equal to 0 degrees or x is equal to 180 degrees for the first one, plus k times 360 I will write. And cosine is half. Calculator will give 60. And so it is negative 60. That's all. K 360s and done. See? So you can just say plus k times 360, k times 360, plus k times 360, plus k times 360. You can say plus minus 60, by the way, because the same value, and k is integer. So this is 4 marks, you know. That's how, if you end up such a question, sometimes maybe tangent square 2 sine, it looks difficult to solve it, but use that thing they gave you. Okay, then 6 is a trick graph question. So drawing a graph, if they ask you to draw 2 graphs, usually it is like 6 marks here. Sometimes they gave one of them, they ask you the other one to draw, so it's only 3 marks. Sometimes both graphs given, you find the equations. But here, it's not 3 marks for one graph, it is 6 marks for 2 graphs. And what are the graphs? It's we have tangent x, and then we have a sine graph which is shifted. So we have 2 graphs. One of them is the tangent, one of them is sine is shifted. And you will be given your answer book. So that's the good stuff. So just be careful. So like here, I don't have any answer book to draw. I need the coordinates myself, because those questions, your answer in the 6.1, you see, in 6.2, it says use your graphs. So 6.2, it is going to help me. That's why it is better to be scaled than everything. All right, so that's important for 6.2. 6.3, they ask the period. So that's kind of easier. What is the period? So I can just answer 6.3. What is y? F of 2x is, it is tan 2x. So what's the period of tan 2x? The original period is 360, but you divide, sorry, the original period of tangent is 180. So you divide 180 by the coefficient of x, answer is 90. So that can be done, 1 mark. So question 3, you don't really need to write the function. It's only 1 mark, 90. So 6.3 can be done separate. But those other 6.2, I must have 6.1. Okay. Now, would you use the calculator? Nothing is wrong. Steps can be 45. Yes, because this one is shifted as well. So let me just do, which one you prefer me solve it, or we can minus 80 to 180. So what are the asymptote lines for tangent? That will be at 90. So I can draw an asymptote at 90 somewhere there, and I can draw an asymptote at negative 90. So I have 2 asymptote lines. Then the sine graph will be a shape, but then it is shifted. So let's plot them. So 45. So it's shifted what, 45 degrees to the
Right.
no, 45 degrees left. Okay, thank you. So it will start at there 45. And when it is plus 45, it will reach at 1. So let's say this is 1. And then it is when 135, it will come there, and 180. So I will stop at 180 somewhere here, and minus 90. So the graph will be basically for sine. I can just say that will be my curve. And yeah, it will be just going like that, and that is 1. And for tangent all is fine. It's just the 10x graph. Tangent 45 is 1, so it is passing through the same point, and tangent 0 is 0. Tangent 45 is negative 1, so it will be like that shape. And even here, it will be tangent 135 is minus 1. So it will come like that, 180. At 180, it will be 0. So that's 180, that's 135, that's 90, that's minus 45. So I just try to draw, but you can plot it. That's 6 marks. Drawing this. Be careful with drawing the asymptote lines and special values, those 45, 90, minus 90. No, then you get your full 6 marks. Now, the answer in the previous question, you see, they indicated us to stop only, the answer is only between minus 90 and 90. You know what? Because after 90, like they intersect again, and there's a small problem, we don't know that intersection. I mean, we can solve it. Yeah, it can be solved, but it will take time maybe. And then there is not a quick method to solve it, by the way. Yeah, it will be very tricky to solve. So that's why they just restrict the domain with the minus 90 and 90. You see, that's important. Don't worry about what's happening after 90. So we will be just looking the graphs in between the yellow lines. Okay, we'll be just looking at the graphs in between the asymptote lines. So asymptote lines are the yellow lines, x negative 90 and x 90 is our asymptote lines, vertical asymptotes, the asymptotes of tangent, the yellow lines. So in between this, we will be looking our answers. And is there anything I know? So I know that's minus 1. So 1 and minus 1 are the special values, and that's it. Now, it says, use your graph, determine the values of x in the interval. F g minus f is 1. So, you know, it means like when g is 1 more than f. So which one is g? F is the tangent one, the green one. So f is the green one. And then g is the red one, the sin x, G. F is the green one, so that's F. So what's happening? G is one more than F. So you can see, you can clearly see it is when it is x minus 45. G is one above, the red line is one above the green. And then the green gets close and close. You see, the green and red gets closer and they intersect at 45. And then green is more. We don't want it. The only answer here, it is one more, is that minus 145. So there's another answer at 135. So that's minus 45. The other answer is like in 135, but you don't need to write it. The only answer in this interval is going to be, you will write x is equal to negative 45. That's it. Okay, over there, that will get us. Yes.
So the red one is G, right?
Yes. G is
and
one
the green
more.
one is F. So then, sir, at when they intersect, the y-intercepts, G is 1 and F is 0. So then 1 minus 0 would be 1, sir.
When they intersect, they both equal to 1. The difference is 0. But at x is minus 45. G is 0. Sorry. G is 0, yes. And F is minus 1. See, G is 0 and F is minus 1. So 0 minus minus 1 is plus 1.
Oh, okay.
Okay, so it is 0 minus minus 1 is plus 1. So that's fine. And then the other one is, that's why actually they restrict the domain, because we will just look what was it? G above F. So in your graph, red above G. Red above green. So red above green from minus 190. Okay, what could be tricky here? Minus 90, you cannot include it because the other graph is undefined. Till when? Till the time they intersect. So they intersect at 45. So red one is above from minus 90 till 45. Only 45 I can equate, not 90. So that's a small tricky detail. So this I cannot make equal 0 because it has an asymptote. Okay. Cannot be equal. Why? Because of what's the asymptote line. Otherwise, that's the answer. You just write minus 90 to 45. But look at the original question. It has equal sign. You see, but now you don't equate both of them. Is it okay?
Yes.
So you draw with the calculator, whatever, it is okay. They don't mind how you use the table. You don't need to draw show the table or anything. Just draw, showing all these necessary points, intersections, asymptotes, whatever. And then look, using the graph, we answered those 6.2 and 6.3 we already answered. Okay. Now, question 7. If you have any specific questions during these sessions, we can look them. Otherwise, maybe let me just go in order. So we can try to solve as many questions as possible. You have the memorandums anyway, you can always look there. Before the classes do that, so we can just answer quicker. We can just approach the questions you struggle. Okay, question 7. Now, it's kind of a long story, but the 3D shape, you can obviously see there's a 3D shape. So the 3D shape questions, you will realize there's this bottom horizontal triangle, and there's left and the right sides. They are the vertical ones. And we can say they are right angle triangles. You can even see they put that 90 degrees thing. And then what else? And the inclined one, the one like ABD, you know, that's like inclined surface. But we don't have a surface actually, it's just the distances we are talking. See, it says that there's a tree, CD, so D is the top of the tree, and the shadow was marked at point A and B in the same horizontal plane. Okay, so C, and from C to D, AB will be the shadow, different times of the day. The shadow of the tree rotated Z degrees between, so that angle is Z for the rotation of the shadow. Okay, that's fine. And then what else? The D is that distance AB. K as that angle ABC. So this angle is K, that is given. That's fine. And Y is the angle of elevation. So they already tell us what angle is Y. And then now, is it going to, so I can just ignore the writing now. I have everything on the diagram. So does it help me to just draw separate triangles? It may be, but I don't want to spend like 10 minutes for just drawing something and thinking on it. But if you can quickly draw without ruler, you can. Like you don't need to have a ruler, but you can just have, there's triangle ACD, the one on the left side. Good. There's triangle DCB, the one on the right side. So you can just quickly draw with free hand. Nothing is wrong. And then there's triangle AC. I don't think I need the inclined one, so I will ignore. I am not going to draw the inclined one, or let me draw it on the top. So I don't need it most probably, but let me just draw. You see, the last one I draw is not really I need it. So this is D, A, B. I can ignore it, but there is A, D, C. So A, D, C. What I know here is that is 90, and this is Y. That's good. And there is D again, there is C, there is 90. What I know here, that is H, okay, that's H as well. And that is B. So, and this is B, so there is K, that's good. There is D, there is A, and there is C, and there is Z as well. So as you obviously, as you obviously see, which two triangles might have lots of information so that we can use it? Obviously, you see it's like this triangle, there is Y, there is H, there is 90 degrees. And I'm going to use that one and this one. So I can ignore the other triangles. You see, that's what the point now. I don't really need it to draw them, whatever. I will use these two yellow ones. That's I can focus. And when you choose that, you can actually highlight that the bridge, their common side. Their common side is AC. So I will definitely, AC is an important side for me because it's connecting them. Okay. They might ask the questions in steps, like it looks like they're asking question steps anyway. But now, even if they don't ask, you see, they can ask 7.3 straight. So you see, this whole thing from 7.1 to 3 is 5 marks. So you may get a 5-mark question, 7.3 straight. But looks like they put the questions into steps, which sometimes they don't do that. You see, they ask a straightforward 3D question, 5 marks, 6 marks straight. And that is when what we do here is important, you know, thinking on the triangles, deciding which two triangles can connect, what can I write, whatever. But actually what we are thinking, they already ask in 7.1 and 7.2. So what's 7.1? Find AC in terms of ZKD. So I have AC, yes, and ZKD. So it's basically triangle ABC. So is it a right angle triangle? Can I use SOHCAHTOA? No. What can I use? You see, let's write that as well. Only those right angles, the ones that you use SOHCAHTOA. So I can use SOHCAHTOA. Nothing is wrong in the vertical triangles because they are the right angle triangles if I have to do something with them. But if a triangle is not right angle, then most probably it is sine rule, area rule, you know. So the rules, let's say it can be cosine rule or sine rule. In this case, looks like it is sine rule. Like you can see, let's write the sine rule, AC over opposite angle, sine K, is equal to D over opposite angle, which is sine Z. So that's it. You will just leave AC alone. So if you leave AC alone, it's kind of cross multiplication, or you can just write AC, let me write up there. What will be the answer then? AC is, oh, that's so thick. That's right, in a normal. So AC is D times sine K divided by sine Z. So that is 2 marks. Just write cosine rule and leave AC alone. Now in the second one, write AC in terms of Y and H. So it's in the other triangle now. And I will use SOHCAHTOA. So what's the relation between Y, AC, and H? It's the TOA, SOHCAHTOA. It's tangent A. So you say tangent Y, sorry. Tangent Y is what? Opposite, which is H, over adjacent, which is AC. So now Now I can leave AC alone. So what is AC? You can swap H over tangent Y. So that's what they wanted. And even if they didn't ask this, if they asked this question straight 6 marks, I was going to do the same thing. And I was going to equate them to get the, see, next question is only 1 mark. It deserves maybe 2 marks, but anyway, or this whole thing deserves 6 marks. They ask alone. But that's how they ask trick questions. So just please get that idea, you know, they can ask this whole thing straight. So that's how you are thinking and what you are thinking. So, and in the last step, what you do, you can just say H over tangent Y is equal to, what is the other one? D times sine K over sine Z. Good. So how do you leave H alone? Just write what they wrote. That's it. Because you're just going to take tangent Y to the other side. That's it. Yeah, that's why it's 1 mark. And the other thing, 7.4, that type of questions, usually it is just substitution. Huh? But is it like, you can just check, is it really just substitution? You can just check, like H is the question. Do we know D? Yes, 80. So it is 80 times. Do we know K? Yes, it is 38. So it is tangent 38 times. Do we know Y? It is 40. So it is tangent 40. And then what else? Do we know Z? Yeah, 125. So divided by, what was it? Sine. You say, I just copy paste the formulas, just substitute, and calculator will give you the answer. And please, in that case, that 2 marks is very cheap mark. Huh? You don't need to know nothing in this section, but you can get that 2 marks, please. So actually, that will be like the cheapest mark in the paper, maybe you can say. Like when your reading time is there, you can just answer this question in the first minute of your paper before answering anything. Just substitute, your 2 marks is in your pocket, just like that, imagine. So that's how you can identify the question, maybe one of those questions, okay, I can get 2 marks, just do that. As long as you don't make any silly mistakes, silly substitution, whatever. Okay, so that was a 3D question they asked. And yeah, as I told you, they may ask 7.3 straight without the steps, but you will do the same. You will think in the same way and write the same story. Now, there's this question. It says there is tangent A and tangent B. So let's see what can be done. There are intervals. Do we... It doesn't say no calculator, so we can think of using calculator. And it doesn't say, you see, B is an acute angle, but A is not. So, but first of all, like what would you do is leave tangent and sines alone. And such things sometimes just 1 mark. You know, you can just do it like you can leave 10 alone. You can say 10A is 4/3, and then you can say sine B is 1/2. You see, sometimes this is like 1 mark in the marking sheet. You can see, so it's good. Now, using 10A, I must find the sine A, and using cosine sine B, I must find tangent cosine B. Now, that is special angle. That wouldn't be a problem. I can just get it. But for A is 4/3 is not a special angle. So I should be using calculator, since it doesn't say no calculator. Why not? So actually, let me use calculator in the first one then as well. What is the angle B? Angle B, what makes a sine 1/2? It's special angle 30 degrees. So now I will substitute B with 30. Good. What about A? What angle is A? Then you will use calculator. Tangent inverse 4/3 will give you the angle value A. But be careful, the interval, I have to add 180, yeah? Because whatever the answer is not an acute angle. The answer is more than 180. So remember the rules for tangent equations, general solution is plus K times 180. You can add 180, and in this case, we should add 180. Okay, we should add 180 to find the value of A. And then I'll just plug in those values into A, into the equation, and get my answer. All right, you can check the remaining of this from the memorandum. Now, the next question Next question is derive cos A formula. Actually, yeah, that's not a problem. You're just gonna write what? A plus A, then it will be done. It's all about writing the A as A plus A. So formula can be applied. I hope you are fine with that. 5.3, prove that question. There's only one double angle, sine double angle, but it's minus in front. And then let's see if we have the sine double angle, but the left side is only one term. See that there will be some sort of factorization, definitely, but what? No, that's the point sometimes. Now that cosine square minus cosine square plus 1. So it's just written the way that we don't usually familiar with that. You say in the previous thing I write sine square plus cos square is 1, isn't it? So you know that. So that's fine. So you can take a cosine square other side. Basically sine square is cos square minus sine 1 minus cos square. That's fine. But the thing is 1 minus cos square can be written minus cos square plus 1. So it's the same thing. And that's what is written here, you know. It just made it a little bit, you know, that whole part is actually sine square, this part. And just give a few seconds to realize that, you know, to focus that. And please do that when you're reading time in the exam. So that's definitely double angle, but that minus, I have to take it out first. So anyway, normal process says what? You'll say left-hand side, and I'll write negative sine theta, and then I'll just say plus sine squared. You see, you know why I made it sine square, I explained about. So the one numerator, I can do nothing. And basically with the double angle rule, then it will be factorization so that we can get the answer. So cosine theta, so we can have a negative, oh, what is sine double angle? Negative 2 sine cosine, negative 2 sine cosine plus sine square over that whole thing. What? Sine plus minus cosine, 2 cosine. So what does the double, what was the double, what is common factor? Sine, isn't it? Just sine. So sine is common factor. You have, or take minus sine as a common factor. So you have 2 cosine and 2 cosine, not square, and minus sine. So it will be, okay, it's like opposite to one that we have. Or we can take minus sine out. Anyway, they'll cancel and you get right hand side. Okay, I believe all is fine. You can take sine as a common factor or minus sine, doesn't matter. At the end of the day, you'll be canceling those things correctly. Just make it correct canceling, okay. So we'll carry on. Just a short break and we'll carry on with this paper. If you have questions, please identify them. So we can just focus your questions. So